This is week 13, day 1. Week 13, day 1. So today we will be discussing the 2011 A-level exam paper. Right. Let's start with. The unit of thermal conductivity is. Unit of thermal conductivity is. So you all know the basic equation. K times A delta theta over delta L. So this is what? Here meter squared. Change in temperature can be in Celsius or Kelvin. Meter. So here thermal conductivity is watt per meter per Kelvin. Watt per meter per Kelvin. Answer is answer number 2. Answer is answer number 2. Right, moving on. The most appropriate instrument to measure external diameter of a soft rubber tube. Rubber tube is. Soft rubber tube is. So what is your variation? So here meter ruler is there. Micrometer screw gauge. Vernier caliper. Spherometer. Travelling microscope. So the most suitable one will be what? Travelling microscope. Because all other instruments you have to apply pressure except for spherometer. Right? Moving on. Third. A simple pendulum of periodic time T on Earth is brought to the moon. If the ratio of the acceleration to gravity of the Earth and the moon is 6, period of oscillation of the pendulum. So on Earth you can say T equals 2 pi square root L over G on Earth. On the moon, 2 pi square root L over G on the moon. If you divide one equation by the other, Tm divided by T is square root Ge divided by Gm. So acceleration due to gravity on Earth is much more larger. The ratio there is root 6 times T. So root 6 T is your answer. Correct answer, third one, is answer 3. Right. Moving on. MCQ number 4. MCQ number 4. Final image of a compound microscope at normal adjustment. It's formed at the least distance of distinction. It's formed in front of your eye, virtual, inverted, larger than the object. Yeah. Virtual, inverted, it can't be real. All these answers are wrong. Correct answer is this. So fourth one, answer number 1. Fourth one, answer number 1. Right, moving on. MCQ 5. The figure shows the shape of a tsunami wave of wavelength lambda and amplitude A. The speed of the wave can be approximately given by V equals square root GD, where D is the depth. When the wave reaches the beach, depth reduces, velocity reduces, kinetic energy reduces, but gravitational potential energy will increase. Gravitational potential energy increases means height will increase. So velocity is proportional to wavelength. So V reduces means lambda reduces, but height will increase. So your simple variation here is lambda and V will decrease because V is proportional to lambda. V decreases, lambda decreases. The first one is wrong. Lambda can't be the same. They can't increase. They can't all decrease. Most suitable answer is this. Lambda and V reduces, A will increase. A will increase. Right, moving on. Here you go. A source of sound is moving to the right with a speed faster than the speed of sound. So moving to the right means this way. So pressure cone is formed in that direction. Correct answer is answer number 1. So pressure cone is formed there. Right. Which of the following gates cannot have more than one input? Now a NOT gate can't have more than one input. We take a NOT gate. One input. Yeah. One input is there. So here 7th one, answer 4. Right. In an automobile engine, a mixture of air and petrol in the cylinders is compressed to 1/9 of its initial volume. So I'll draw here will compressed to 1/9 the initial volume. 1/9 the initial volume. The initial pressure is 1 atmosphere and the initial temperature is 27 Celsius 300 Kelvin. If the pressure after compression is 21 atm, temperature of the compressed gas is, so P1 V1 over T1 equals P2 V2 over T2, assuming it's ideal. We are assuming it's ideal gas. So once you assume it's ideal, 1 times V times 300, that is equal to 21 times V over 9 times T2. V over 9 times T2. So what will you get from this relationship? Here you go. You will get VV cancel off. Simplify this. T2 equals 21 multiplied by 300 divided by 9. So here divide by 3 times 1, 7, 700 Kelvin. So your relationship there is 700 Kelvin. All answers are in Celsius. So 700 Kelvin minus 273, 427 Celsius. Correct answer is answer number 3. Correct answer is answer number 3. Right. Moving on. A planet of uniform density, that means same density, has a mass 2 10 to the power 27 kg, radius is 6.7 10 to the power 7. The gravitational potential at the surface of the planet is, so at the surface means here let's say the radius is r, at the surface means potential is equal to minus gm over radius of the planet, right? So here minus 6.7 10 to the power minus 11, mass is 2 10 to the power 27, radius of the planet is not given, given 6.7 10 to the power 7, 6.7 will cancel off, 6.7 will cancel off. From here you can simplify it to 20 10 to the power 9 minus joule per kilogram. So 2 10 to the power 9 minus minus value. There you go. 9th one, your answer is answer number 1. 9th one answer is answer number 1. Right. MCQ 10. When a beam of 100 kilo electron volts is stopped in a target metal. Now normally, if you are stopping an electron in a target metal, guaranteed X-rays or photons are going to be emitted. In your syllabus, you have X-rays. So guaranteed this answer is X-rays. Right. Moving on. An electron of mass me when accelerated through a potential difference has a de Broglie wavelength lambda. The de Broglie wavelength associated with the proton, right? So normally lambda is equal to h over momentum. H over momentum. Momentum is equal to square root to me. Now this is in mechanics, very famous relationship. So lambda is equal to h over square root to me. E is kinetic energy. Kinetic energy you can write as potential difference into charge. So lambda is equal to h times square root 2m v times q. Right. So what have they given you? De Broglie wavelength for a proton is given. For electron, sorry. So lambda, potential same, charge same, h same. So lambda square root me we can say. Also lambda dash. A proton. Divide the second equation by the first, lambda dash over lambda square root me over mp. Lambda dash is lambda square root me over mp. Check and see whether you have that answer. Answer is there, no? Answer number 2. Right, moving on. A block of mass m is placed on a wedge. Right. What are the action reaction forces? So A and B looks like action reaction. E and C looks like action reaction. So A and B, E and C are action reaction forces. Right. Question 13. A space shuttle B of moment of inertia I2 angular velocity omega 2 joins smoothly with moment of inertia I1 angular velocity omega 1. So total initial angular momentum equals total final angular momentum. Total final angular momentum. So here you can say I1 omega 1 plus I2 omega 2, both are in the same direction. If you apply the right hand rule, there you go, right hand rule, upwards. Join together I1 plus I2 omega. Omega is I1 omega 1, I2 omega 2 divided by I1 plus I2. I1 plus I2. There you go. Yeah. Okay. MCQ 14. An empty thin wall container, volume V, mass m0, volume V, mass m0, is filled with n number of glass and steel balls. So here mass is m0, volume is V, x number of glass balls. So n minus x number of steel balls. So you are finding effective density, total mass m0 x times mg n minus x times ms total volume V. So effective density of the full system is found. Effective density of the full system. This is given by this relationship. Answer number 5. MCQ 15. Velocity time curve for the motion of a particle is shown in the figure. Corresponding displacement time graphs. So here there is a deceleration, at rest acceleration. So deceleration, at rest acceleration. Correct answer, answer number 5. Correct answer, answer number 5. MCQ 16. A patient with cataract got his eye lens replaced by artificial lens that has a fixed focal length. His vision was then found to be best for viewing objects at a distance of 10 meters. So whatever happens, what's the theory? Wherever you keep the object, the image should form where the eye can see. So here is long sighted. Object is kept at 25 centimeter. Image will form at 10 meters. 10 meters is 1000 centimeters. So you are simplifying this. Here you go. Apply equations. 1 over v minus 1 over u equal 1 over f. Object distance is 25. Image distance is 1000. Focal length f. Common denominator 1000. 1 minus 40. Focal length. F is equal to minus 1000 over 39. Approximately, let's say 40 minus 25 centimeters. So convex lens of approximate focal length 25. Correct answer, answer number 3. Correct answer, answer number 3. Right. Moving on. Figure shows a resultant produced by beats. The beat frequency is equal to. So here the beat periodic time. Beat periodic time is 0.5 seconds. That means this wave pattern repeats after 0.5 seconds. So that's the periodic time. So frequency of the beat is 1 over periodic time. 1 over 0.5, that's going to be 2 hertz. 2 hertz, answer number 2. Right, moving on. Question number 18. Setup shown in the diagram is used to focus a parallel beam of light to point S. Remember, light ray coming from top goes at the bottom, bottom goes on the top. Guaranteed right angle isosceles. Again, top is going at the bottom, bottom is going at the top. Right angle isosceles. Here, converging. Converging means convex lens. Even if you don't know anything else, here the option is between 2 and 5. Right angle isosceles is there here. Correct answer is answer number 5. Correct answer is answer number 5. How much thumb pressure should a nurse apply in administering an injection? Injection syringe guaranteed Poisson's equation. So here, Poisson's equation. Poisson's equation Q dot equals pi over 8 eta L R to the power 4 delta P. So volume flow rate is the same. Volume flow rate is the same. Q dot. Same liquid. Same length. So pressure difference is inversely proportional to 4th power of the internal radius. 4th power. So pressure difference here, first instant, radius is 0.1 to the power 4. Second case, 0.4 diameter, 0.2 to the power 4. Divide first equation by the second. Delta P 1 over delta P 2. 0.2 over 0.1 to the power 4. That's going to be 16 times. 16 times answer number 5. 16 times answer number 5. Question number 20. Number 20. Image I formed by a concave lens L of an object pin O mounted on a stand. Concave lens means you get virtual upright diminished images. Virtual upright diminished images. So this is diminished upright. Correct answer is going to be answer. All the others. This is the object. Object should be normal size. It can't invert. This is slightly diminished. Actually, it's diminished by a lot. Right. So here, correct answer is answer number 1. Okay. Answer number 1. Okay. Moving on. Moving on. Structured read. Here, figure shows a spherometer. Figure shows a spherometer used in a laboratory. Number of divisions. Number of divisions Number of divisions in the scale is 50. Linear progression made by the scale in the vertical seat for 2 complete rotations. Be careful. Pitch is 1 complete rotation. Right. In such determinations, spherometer is placed on a curved surface of lens as shown in figure 2. After obtaining the measurements h and b which are shown in the figure, the radius of curvature r can be determined by the following formula. So r is equal to b squared. This is b squared over 6h plus h over 2. B squared over 6h plus h over 2. Right. Moving on. What is the least count? So least count is screw pitch divided by number of circular scale divisions. Screw pitch divided by number of circular scale divisions. Screw pitch is going to be 2 rotations 1 millimeter, 1 rotation 0.5 millimeter. Number of circular scale divisions 50. So 0.01 millimeter. 0.01 millimeter. Moving forward. Before placing the spherometer on a curved surface, it has to be adjusted, placing it on a flat glass plate. How do you experimentally make sure that the tip of the screw touches the glass plate? So you rotate the screw until the tip of the screw touches the tip of the image. That should be the statement, right there. We rotate the screw such that the tip of the screw touches the tip of the image. Very important. Huh? Tip of the screw touches the tip of the image. Right. Then the spherometer is placed on a curved surface of the lens. What adjustment would you make before measuring taking the next measurement in order to find h? You keep the spherometer here in this picture. Now you must rotate the screw where? Downwards. Right there. We must rotate the screw downwards. We must rotate the screw downwards until the tip of the screw touches the tip of the image. Until the tip of the screw touches the tip of the image. Right. What is the reading that you would take from the spherometer after the above mentioned adjustment? So what will you take? You will take the linear scale or pitch scale reading and circular scale reading. You will take the pitch scale reading and the circular scale reading. Pitch scale reading and the circular scale reading. Right. After extensive use, the reading taken from the vertical scale may not be accurate in some spherometers. What's the reason for this? Now the threads of the screw would have worn out. So the screw will easily move up and down. Right there. The threads of the screw be worn out. Therefore, the screw will easily move. Or what can you say? When rotating the screw will move side to side. When rotating the screw side to side. In order to find R, you need to measure the mean distance between the spherometers. What measuring instrument would you use? So B, that meter ruler can be used. Or half meter ruler is also okay generally. Meter ruler. Meter ruler. Or we can say half meter ruler. Right. Some cases they have given answers of vernier caliper as well. Normally meter ruler. What experimental steps should you follow in order to find B? What's the step? Gently press the spherometer on the, rotate the screw upwards. Gently press the spherometer on the white sheet of paper. It will emboss the 3 balancing legs. Rotate the screw upwards. Gently press the spherometer on a white sheet of paper. We join the dots ABC with a straight line. We join the dots ABC to form a straight line, to form a triangle. Measure AB, BC, AC. Measure AB, BC, AC. And find the average distance between two balance legs. Measure AB, BC, AC. And find the average distance between balance legs. Right. Give another use for the spherometer except for the measurement of the radius of curvature. So we can measure thickness of a glass slide. We can also measure depth of a small cavity. Thickness of a glass slide, depth of a small cavity. Depth of a small cavity. Suggest a method to further decrease the least count of the spherometer. So least count is equal to pitch over number of circular scale divisions. Further decrease means reduce the pitch or increase the number of circular scale divisions. Right there. Reduce the pitch or increase the number of circular scale divisions. First one, reduce the pitch. Second one, increase the number of circular scale divisions. Right. Second structured essay. A material called styrofoam, regiform, polystyrene is widely used for disposable cups. The thermal conductivity of this material is less than 0.01 times that of a copper, while specific heat capacity is 4 times that of copper. Right. In order to investigate the suitability of using styrofoam cup instead of copper, a student selected the experiment of determination of specific heat capacity. Right. From iron balls using method of mixture and arrange 2 experimental setups to perform the experiment, one using copper, one using styrofoam. So there is going to be a pilot experiment as well. So one is a copper calorimeter, the other is using what? Styrofoam. Right. After taking the required initial temperature mass measurements, he added iron balls heated to 100 degrees Celsius in the water in the calorimeter and styrofoam and obtained the necessary temperature and mass measurements. So these are your values. Mass of the empty stirrer, experiment with styrofoam cup, mass. Mass of the vessel with water 150-60. Initial temperature 30, maximum temperature of water after 45-47. Mass of final system 300-210. Calculate the amount of heat absorbed by the calorimeter with stirrer. So heat absorbed, delta Q, M, specific heat capacity, delta theta. Heat absorbed by the calorimeter with stirrer, 100 grams. Copper 375. Change in temperature is 45 minus 30. 45 minus 30. So 375, 1.5. 5, 7, 105 and 7, 12, 45, 56. 562.5 joules. 562.5 joules. Right. Using the data obtained with copper calorimeter, show that the specific heat capacity of iron is 450. So heat given equals heat absorbed. Who is giving heat? Metal is giving heat. So what's the mass of the metal? Mass of the metal is very simple. 300 minus 150. 150. 150.15. 450. Change in temperature 100 minus 45. Who is absorbing it? Calorimeter is absorbing, already found, 562.5. Water is absorbing heat. Water is absorbing heat. Mass of water is 50. 50 grams. Mass of water is 50 grams, 0.05. 50 grams, specific heat capacity 4200, 45 minus 30, right? Simplify this, 0.15, 450 into 55, 562.5, simplified 0.05, 4200 into 50. Show that the specific heat capacity, right? We'll find it. So that specific heat capacity of the metal. So once you do the substitution correctly here, and from this you can say specific heat capacity is 450 joules per kilogram per Kelvin. Right. Taking the specific heat capacity of iron as 450, calculate the amount of heat absorbed by the styrofoam cup. Assume that the heat lost to the surroundings from the styrofoam cup and the heat absorbed by the plastic stirrer is negligible. So heat absorbed by the cup. Mass of the styrofoam cup 10 grams. 10 grams. Heat given equals heat absorbed. Who is giving heat? Metal giving heat. So final mass 210 minus 60. 210 minus 60 is 150, no? 150, 450. Change in temperature is 100 minus, carefully look. Final temperature is 47. Final temperature is 47. Who is absorbing it? Water is absorbing. Mass of water. Mass of water is 50 grams. Mass of water. So here 50 grams, 0.05, 4200, 47 minus 30. Heat absorbed by the cup. Cup is 10 grams, 0.01. Specific heat capacity of the cup. We don't know that. They are asking you to find heat absorbed by the cup. Heat absorbed by the cup. Simplify the relationship here. If you simplify the relationship here, you will get 7.5 joules. 7.5 joules. Right. In heat experiments where styrofoam cups are used, the amount of heat absorbed by the cups can be neglected compared to the copper calorimeter. Justify your statement. Heat absorbed by the cup 7.5 joules. Heat absorbed by the calorimeter 562.5 joules. Which is bigger, which is smaller? We can compare it. Nothing to compare there. One is 562.5. So we can neglect heat absorbed by the cup. Heat absorbed by the cup. There. Heat absorbed by the cup. right? We can negate heat absorbed by the cup, right? Okay. Then what? State a practical advantage. State a practical advantage of using styrofoam cups compared to copper calorimeter. So practical advantage means when you hold the cup will not get heated. The customer can hold the cup easily. That's one reason. Okay. Right there. The customer can hold the cup, or the cup can be held without burning the hand. The cup can be held without burning the hand. That's one. Next is styrofoam is much more cheaper. Styrofoam is much more cheaper. Next one, lightweight. State the practical advantage of using a styrofoam cup compared to a copper. Now what happens is the amount of heat absorbed by the cup is less. So heat absorption is less. Heat absorption is less. So the heat absorption is less means more heat is absorbed by the liquid inside. Right there. So heat absorption is less. So there is no need for insulation. Heat absorb is less. There is no need for insulation. Those are the scientific reasons. Heat absorption is less. There is no need for heat insulation. Alright. Copper calorimeter cannot be replaced by styrofoam cup in the verification of Newton's law of cooling. Give two experimental reasons. Give two experimental reasons. Now, in Newton's law of cooling, the whole idea is when there is heat loss, temperature of liquid inside and temperature on the outer surface both should be what? Same. But in a styrofoam cup, inside temperature, outside temperature will be different. Right there. In Newton's law of cooling, the temperature of liquid inside the vessel and outside the vessel on the surface should be the same. The temperature of the liquid inside the vessel and the outer surface temperature should be the same. But in a styrofoam cup, there will be a temperature gradient. In a styrofoam cup, there will be a temperature gradient. Right. Okay. Second one here. What else? The rate of heat loss to the surrounding is going to be very small. The rate is going to be very small. So it's difficult to draw a cooling curve. Right there. The rate of heat loss. Is going to be very, very small. The rate of heat loss is going to be very, very small. Right. Moving on to the essay question. Now, for the essay question, you solve this in the board. Easier. Right. So, all of you have the question. I'll just show it once for you all. A capsule is free to move. Capsule is free to move downwards. A wire, one end which is fixed to the pulley of radius r and wrapped around the pulley is used to hang the capsule. Assume that the mass of the wire and the friction between the wire and the pulley are negligible. The pulley is free to rotate above the horizontal axis. Answer the following question should consist only one relevant quantities represented by the given symbols. For this part, assume that the mass of the pulley and the friction force against the rotation is negligible. if the capsule of total mass m is released from rest, using law of conservation of energy, obtain an expression for the speed of the capsule after it moved down a distance h. Right. Look at this carefully. Now, assume that mass of the pulley is negligible. The moment they say that moment of inertia is negligible, don't consider the moment of inertia. Don't consider the moment of inertia. Right. So now we can say pulley is here, mass is there, capital mg. This comes down a distance h. Simple h or capital H, they are giving you a distance, simple h. Right. So total energy initial equals total energy final. For that you can take this as the Gp equals 0 line. Total energy initial is gravitational potential mgh. Total energy final is half mv squared. V squared equal to gh. V is equal to square root 2gh. Square root 2gh. Right. This is your A Roman 1 answer. A Roman 1 answer. Then they are asking you A Roman 2. If you turn back and look, what is the angular velocity? So there is a tangential velocity, no? So once you rotate, there will be angular velocity. V equals r omega square root 2gh divided by r is your omega. Angular velocity. Angular velocity. So right now, okay. Now the second part of the question. Now the mass of the pulley is simple m. Moment of inertia half mr squared. Repeat A Roman 1, A Roman 2. Now if I repeat, this is question number B. Total energy initial, total energy final. Initial is mgh, capital M. Final is half I omega squared, half capital M V squared. mgh half into half simple m r squared omega squared, half capital M V squared. Remember, there is rotation as well as linear motion. We must consider no slip condition. No slip condition. No slip condition means linear velocity equal tangential velocity, omega is equal to V over R. Substitute. Don't be careful with capital M and simple M. Capital M GH equal quarter simple M R squared V over R squared plus half capital M V squared. Right now? Now you can simplify this. Clear? Now you can simplify this. Here mgh quarter simple M R squared cancel off. Half capital M V squared. Multiply by 4. 4 capital M GH. MV squared. 2 capital M V squared. 4 capital M GH. V squared is simple M plus 2 capital M. V is equal to 4 mgh. 2 capital M plus simple M. Whole thing square root. Whole thing square root. So you can keep the relationship like this. There is no issue. Huh? There is no issue. Right. Next part of the question is find the angular velocity. So find the angular velocity. So we can say V is equal to R omega. Now V is equal to 4 mgh 2 capital M plus simple M square. R omega. Omega is 1 over R square root 4 capital mgh 2 capital M plus simple M. Okay, no? Omega relationship found. Omega relationship found. Right. Okay. Moving on now. Now part C. Now part C. Look at this. Practical situation. We must consider resistive torque. If the pulley rotates by angle theta naught, the frictional torque is tau F. What is the work done? So right. Work done by frictional torque is frictional torque into theta naught. No? Right. Theta naught. Roman 2. Next one. Under these conditions, solve A Roman 1, A Roman 2. Right. Now we can apply work energy principle. Work done by external force or torque, increase in rotational or increase in kinetic energy plus work done by resistive torques or resistive forces or torques. Right. Look at this carefully. Now when this is coming down, external work done by external force, because the tensions will cancel off. Mg into H. Increase in kinetic energy means there is translational kinetic energy, rotational kinetic energy. And when this is coming down, there is going to be a frictional torque in the opposite direction. Okay, no? Frictional torque in the opposite direction. Right. So what I'll do is work done by external force mgh. Is the pulley coming down? No. Increase in kinetic energy half mv squared minus 0. Half I omega squared, that's the final, minus 0 plus. Work done by resistive forces. Do you have friction? Yeah, frictional torque is given. Frictional torque is torque into theta. Now be careful. I'm moving down a distance h. Look at the board. I'm moving down a distance h. So the length here is going to be h. I can apply S equal r theta. Length is going to be h. Radius r theta. Theta is going to be h over r. The pulley will rotate by h over r. So go back. Now we can substitute here. mgh half mv squared half I omega squared frictional torque h over r. Theta is h over r. Okay, no? Theta is h over r. Simplify this carefully. No slip condition. mgh half capital M v squared. Be careful now. Half quarter simple M r squared. V over r whole thing squared. Frictional torque h over r. Now simplify. R squared cancel off. Take it to the other side. mgh minus frictional torque h over r, that is equal to half capital M v squared quarter simple M v squared multiply by 4. 4 times capital M gh minus frictional torque h over r 2 capital M plus simple M v squared. V is equal to 4 times capital mgh minus h over r divided by 2 capital M plus simple M whole thing square root, that is your velocity. That is your velocity. So from this, there you go, we can obtain the velocity there. Also you can find the angular velocity. How is that? No slip condition, V equal r omega. Omega is 1 over r 4 times mgh frictional torque h over r divided by 2 capital M plus simple m. 2 capital M plus simple m. 2 capital M plus simple m. Okay. Right now. So I hope you step by step move. Now we must consider the rotation and the frictional work. So that means here there is going to be external work done and frictional work done as well. Kinetic energy will increase in two forms. One is rotational kinetic energy, one is what? Translational kinetic energy. Both ways. Okay? Right. Okay, now? Here, 2, no? Right. Then what? At a depth h0, it travels and stops. But it keeps on rotating. Number of rotations it will rotate before it comes to rest. Interesting. Now this is C Roman 3. C Roman 3. This is the flow just before it strikes the ground. Just before it strikes the ground. Distance travelled is h0. Just before it strikes the ground. Just before it strikes the ground. Right. Now what? Just before striking the ground, the velocity. What's the velocity? 4 times mgh minus frictional torque h0 over r. 2 capital M plus simple m square root. 2 capital M plus simple m square root. Don't forget, here don't put h0 now. They are told in the question h0. So h0 means you must substitute h0. Right. What is the angular velocity? 1 over r. 4 mgh. Frictional torque h0 over r. 2 capital M plus simple m. Right. Now what will happen? It will strike the ground and come to rest. But the pulley will rotate until it reaches rest. Here. Pulley will rotate until it reaches rest. Right. Now think. Why is the pulley stopping? Because there is frictional torque. Here. Now we can apply work done by external torque equals increase in kinetic energy plus work done by resistive torques. Now do you have an external linear force? No. No external torque. Final is 0, initial half I omega squared. Frictional torque is torque into angle rotated alpha. Or we'll say alpha is normally a bit dangerous relationship, no? Alpha is a bit of a dangerous relationship. Okay. So what we do is, we will take torque into theta dash. Torque into theta dash. Okay. Now simplify this. Half I initial omega squared is 1 over r squared 4 mgh minus frictional torque h0 over r 2 capital M plus simple m. Frictional torque. Frictional torque. Frictional torque into theta double dash. I'll slowly try to keep it here, right, dash. Now, best is I saw this in the next page, right. So half moment of inertia, half simple M r squared. Half simple M r squared. 1 over r squared. 1 over r square 4 mgh frictional torque h naught over r over 2 capital M plus simple m. Frictional torque into theta dash. R squared cancel off. Right. Now what is theta dash? M times 4 times mgh. Frictional torque h naught over r divided by 4 times frictional torque 2m plus simple m. Angle rotated found. Angle rotated found. Okay. Angle rotated found. Number of rotations taking place. Number of rotations. That is theta dash divided by 2 pi. So m here 2 pi relationship. So half moment of inertia part half simple m into omega squared. Omega squared means square root will disappear. No? Omega squared means square root will disappear. So no square root. Right. Check whether the calculation is correct. Right. Four mgh frictional torque. Sorry. The 4 is outside. That's the reason. 4 is outside. 4 brackets. 4 brackets. 4 is outside. Okay. Now easy. 4 is outside. 4 is outside. So 4 will cancel off. 4 will cancel off. Simple M frictional torque mgh minus torque h naught over r divided by 2m plus simple m. Simplify 2 pi frictional torque 2 capital M plus simple m mgh minus frictional torque h naught over r. So again step by step, be careful. So here we are simple, here 4 is coming out. Multiply by 4, 4 is coming out. Omega found. Once you know omega, now for the site h naught you can substitute. Remember the 4 is outside. 4 is outside. Then simplify, you can get the number of rotations taking place. Number of rotations taking place. Right. Then what? Then part D. Follow the question. Part D. Capsule, there is a mass m1 that enters the capsule and it travels up with a constant angular velocity. What is the external torque applied? Now look at the board. Now capsule mass is capital Mg. Somebody gets in there m0 g. Pulley is applied here, tension is there. And we are rotating this with constant angular velocity, let's say omega dash. So this is coming up with a constant velocity. Right. What are they asking you? They are asking for the external torque applied. So work done by external forces or torque, increase in kinetic energy plus work done by resistive torques. Work done by resistive torques. Right. So moving up means external torque into angle rotated, let's say theta double dash. Increase in kinetic energy. Translational kinetic energy does not change. Rotational kinetic energy does not change. Increase is going to be 0. Work done by resistive torques. Now when this is going up, there will be a resistive torque where total weight will give you a resistive torque. mg plus m naught g force into perpendicular distance to the axis plus frictional torque theta double dash. Clear? So external torque theta double dash m plus m naught g r, frictional torque theta double dash. Look at the board now. It's traveling up, let's say capital H. S equal r theta. H equal r theta double dash. So frictional torque or external torque m plus m naught g, radius I'll put h over theta double dash, S equal r theta. Sorry. External work done mg into h travel. Sorry. mg into distance travel, no? External work done mg into h. So gh, h is r theta double dash. Frictional torque theta double dash. Theta double dash, theta double dash, theta double dash cancel off. External torque is m plus m naught gr plus frictional torque. There you go. So work done by external forces, external torque one is there. Work done by resistive, weight will do resistive work. Total weight into H, capital H. Total weight into capital H. Force into displacement. And frictional torque. Simplify this, external torque can be found. External torque can be found. Okay. Right, no? External torque can be found. Right. So we have done this whole essay question, huh? Full essay question done. Now the final essay. This is optics question. Figure shows a zoom lens arrangement used in a camera. It consists of a convex lens of focal length f1, focal length f1, it's not printed there, I think. Focal length f1 and a concave lens of focal length f2 with a variable distance d. Variable distance d. The purpose of the zoom lens is to vary the effective focal length with a small variation of d, providing variable magnification of the object. Right. What is the inequality that should be satisfied by D and F1 in order to form a real image? Or to form a real image. Right. So real image means light rays coming from here will converge to this point here. That is your focal length. That is your focal length. So what is your condition? F1 should be greater than D. Easy, no? F1 should be greater than D. Right. Second one. The lens combination forms an image I at a distance V to the right of the concave lens. Derive a formula. Right. Now, image of the convex lens is object for the concave lens, and this is the image for the concave lens, convex concave. So object distance here, what is your object distance? F1 minus D. Image distance is V. So let's apply lens equation here. 1 over V minus 1 over U equals 1 over F. Object distance is in the direction light travels, F1 minus D. Image is formed in the direction light travels, V. Focal length, concave lens plus F2. Plus F2. They are asking an expression for V, multiply by minus 1 over V, minus 1 over V plus F1 minus D 1 over F2. Simplify it. 1 over F1 minus D minus 1 over F2 is equal to V. F2 minus F1 plus D. F2, F1 minus D 1 over V. Turn upside down. F2, F1 minus D. F2 minus F1 plus D. F2 minus F1 plus D. So you can see whether you got the answer. F2, F1 minus D. F1 minus F2 plus D. Right. So I have already put the sign convention there, so the value for V will come. Right. To determine the effective focal length of the combination consisting of parallel rays of the convex lens at distance r0 of the principal axis. Right. What are they asking you? What are they asking you? Show that the distance r from the optical axis to the point it enters the concave lens is given by this relationship. Right, let's see. Here let's say angle theta. Angle theta. This is F1. So this is F1 minus D. So we can say tan theta is equal to opposite over adjacent R0 over F1, also smaller triangle, simple R over F1 minus D. So simple R is equal to R0 F1 minus D over F1. F1 minus D over F1. Right. Done. If the ray shown in figure 1 that emerges from the concave lens and reaches final image I is extended backwards to the left, it will eventually meet the incident ray at point P. The distance of the image I to point Q is the effective focal length of the combination. Right. So if I extend this backwards, this is called the effective focal length. Nice. From here to here, this is called effective focal length. This is called effective focal length. Okay. Right. What are they asking you? Show that the focal length is given by this relationship. F1, F2 and the particular value. Right. Okay. Let's go back to geometry below. Right. So V we have found. So distance from here. Effective focal length is D plus V. Effective focal length is D plus V. Now you don't know this distance, so you must find it. So here they are given you this distance is R. Okay, now? Right. So location of the image to point P will give you effective focal length. Effective focal length. Right. So image I to point P, I to Q is your effective focal length. So they are giving you focal length is F. Okay. So now you must find this. So actually for V we have found V plus D will give you the required length. V plus D will give you the required length. So we can use this geometry here, no? At once. We can use the geometry there. This is R naught. Otherwise, if you are trying to add this to this, we don't know that distance. At once we can get the relationship here. So let's write it. I will lead it like this. I'll name this angle as beta. Tan beta is opposite to adjacent. Tan beta is opposite to adjacent. Tan beta opposite to over adjacent. Also we can say tan beta is opposite to adjacent here V. R over V. R over V. R over V. Effective focal length is R naught V over R. Effective focal length R naught over R. What is V? Now value for V, we have applied sign convention and found F2, F1 minus F2, F2 so we have proven this, no? F2, turn back and look, be careful when you substitute, otherwise you get the whole thing wrong. F2, F1 minus FD. F2, F1 minus D divided by F2 minus F1 plus D. Let's see. F2 minus F1 plus D. Right. Okay. So from this you can find the effective focal length. Effective focal length. But they don't want in terms of they don't want R naught to R. No. So R naught to R, let's substitute. R naught to R here. R naught to R is F1 divided by F1 minus D. F1 divided by F1 minus D. Substitute. Effective focal length F1 divided by F1 minus D. Here F2 F1 minus D, F2 minus F1 plus D. These two cancel off. F1 F2 divided by F2 minus F1 plus D. Effective focal length. Effective focal length. Check. F2 minus F1 plus D. Correct. Done, na? Correct. Now what? If F is 12, F1 is 12 centimeters. F2 is 18, separation D is adjustable between 0 and 4. Find the minimum and maximum focal lengths. Effective focal length f1 f2 divided by f2 minus f1 plus d. 12 times 18, 18 minus 12 plus distance moved 0. So lesser value means maximum focal length. 12 times 18 divided by 6, 36 effective focal length centimeters. This is your maximum. Effective focal length minimum. 12 times 18 divided by 18 minus 12 plus 4. 12 times 18, 6 plus 4 is 10. 36, 3, 21 over 10, 21.6 centimeters. So effective focal length maximum is 36. Minimum is going to be how much? 21. Minimum is 21. Do your results justify the purpose of the zoom lens? Give reason. So I am moving the distance 4 centimeter and the focal length is changing from 36 to 21. Yes, no? Correct. It is justifiable. Clear? Right there. Answer is yes. For a small change of 4 centimeter, focal length changes from 36 to 21.6. Focal length changes from 36 to 21.6. Okay. Right. Okay. So that concludes week 13, day 1. See you next time with week 2 of week 13, day 2. See you.